Okay, so we are going to be talking about free body diagrams right now, and a free body diagram shows the force vectors acting on an object. So there are some steps that we're going to take, and here we have an apple that's in free fall, and we're going to represent the apple with a point like that. That's the apple. So this is the free body diagram, FBD, free body diagram. And because the apple is the only thing, or because the apple is falling, there's only one force pulling on the apple in the downward direction, and that's going to be gravity. And we use a W with a vector symbol above it to represent the gravity force, which we call weight. So the weight of an apple is the same thing as the force of gravity. So we could do this as well with a G below it, representing force of gravity. Okay. Notice it's a negative direction, and you'll see why we actually get a negative value for it, because the weight, which is caused by gravity, is equal to the mass times acceleration. Well, the acceleration of gravity is known. It's negative 9.8 meters per second squared. And we know that from first semester. So if I'm calculating the weight of the sled, I would calculate it by saying that weight was equal to the 8 kilograms of the sled times negative 9.8 meters per second squared. Now I want you guys to really understand that this is about 78.4 negative, and that would be newtons because it's a weight or a force. Okay, and we have one thing I need you guys to understand is that mass and weight are very different things. Mass does not equal weight. Weight is a force that is caused by how hard gravity pulls on the object. Mass is just the object itself. Okay, same thing with pounds. When we get our quote unquote weight in pounds, when we're weighing ourselves, we're actually getting our mass and with the gravity pulling down on you. Okay, so be careful with this word weight and mass. All right, here we have a sled that's sitting on a porch, and now we're adding, now the sled's not in free fall, the apple's not in free fall, whatever. Now it's actually stuck, and it's kept from falling by this surface. And this surface here, this surface is what we call a normal force. Now, that you can put right in here, normal force. And we use a capital N with a vector symbol above it. And the normal force is the force of a surface pushing on the object. Now, which direction is it pushing on the object? That's a good question. If you were to draw the surface as your x-axis, then the normal force would go along with your y-axis. Okay, so if this is x and this is y, then your normal force would go with the y-axis, and we would say that it is perpendicular to the surface. Perpendicular to the surface. So the way I would draw the free body diagram, I would use a point for my sled. I would draw the surface in, so I have some kind of reference. And then I would go ahead and draw the normal force pulling up. Or pushing up, I should say. And again, it's perpendicular. So what exactly is a normal force? A normal force is a support force provided by a surface. So it only exists if there's a surface. Okay. It is always perpendicular to the normal, or perpendicular to the surface. So take a look at these two pictures. Here you have the surface pushing up, and it's perpendicular to the surface. And then here you have the surface on an angle, but notice that the normal force is still perpendicular to that. And I also want to point out the weight force is always pointing straight down to the center of Earth. So that stays the same. Your normal force is the thing that turns or twists with your surface depending on where your surface is. Okay? All right, so now we have another force that I'm going to introduce you to. You have a sled that is supposed to be going down the hill, but it is not going down the hill because there is not enough snow and it's kind of stuck on some patches of grass. Okay? And what is that force that's acting on the sled? Well, that force is the friction force. You also need a surface for friction. Our symbol for friction is a script F, or a lowercase f. And if I were to draw the free body diagram with this guy, I would put in my surface, because there's a surface. And my sled would like to go down the hill, but friction is keeping it from doing that. So friction is actually pulling the sled up the hill. That's what's keeping the sled from sliding down. So there's my free body diagram with my friction in it. And so the definition of friction is the resistance to motion so resistance that occurs whenever two materials are in contact with each other. Alright, so take a look at this picture here and I'll explain it. You've got a box on a surface and we are pushing the box to the right, so the motion of the box should be to the right. However, friction is going to oppose that force. That's what this word oppose means. It's going to push against it. It's going to try to stop it. It wins sometimes when you can't move a piece of furniture across your carpet because it's too heavy, too massive, and the carpet is keeping it there. So friction can stop an object from moving, or it can be really, really minimal, like on a sheet of ice, and it can, have hardly any effect on it. All right, and we're going to pause the video right there, and we'll start up the next video with the next slide.